Hi children, welcome to another episode. Blast with the past, the previous year questions discussion from the JEE Advanced paper. Here which one? 2021, a question from JEE Advanced 2021. Let's see the question. The reaction sequence or sequences. So it seems to be more than one choice correct, right? It should be from more than one choice correct. There comes such a comment that would lead to orthoxylene as major product. So we want orthoxylene as major product, is or are. So which all choices will satisfy that condition? Orthoxylene, all of you know, 1,2-dimethylbenzene. From where you can get 1,2-dimethylbenzene? Let's see first one. We have methyl group here and NH2 group here with the NaNO2HCl. You will get what do you get? NH2 group will turn diazonium salt. So NH2 group will turn diazonium salt, N2 plus Cl minus. Then what next? CuCN, that is Sandmeyer's reaction. You will get a cyano. So NH2 will turn diazonium salt. Further with the CuCN, it's very simple to understand Sandmeyer's reaction. So you will get NH2 will become Cn now. And then with the dibal H, so the first 1 and 2 reaction or reaction 1, after reaction 1, it will turn like this. After reaction 1, after reaction 2, that is Sandmeyer's reaction, it will turn like this, isn't it? Methyl group here and Cn here. What is next? Dibal H. Nitrile with the dibal H. What is happening? You will get a aldehyde. So CH3 here, Cn group will turn aldehyde. CHO group because it is dibal H. Diisobutyl aluminum hydride. All the reactions are there in NCERT. You will get aldehyde. And what is the last reaction? So this is after third reaction. Last reaction, what is that? Wolff-Kishner reduction, isn't it? Wolff-Kishner reduction will turn CHO group to CH3 group, and option 1 is a perfect choice for what we are looking for. Already there is a methyl group and there is a methyl group over here. You get orthoxylene, 1,2-dimethylbenzene. So first choice will be a perfect answer, no doubt about it. So what all things happening? NH2 turn diazonium salt, reaction number 1. Reaction number 2, Sandmeyer's reaction, this turns Cn. And reaction number 3 with the dibal H, or it may be Stephan reduction, isn't it? You will get a CHO, and CHO, Wolff-Kishner reduction or Clemmensen reduction, you will get a CH3. Right? So first choice is a perfect one. Now second one. This one. There is methyl group and bromine, first reaction, magnesium carbon dioxide hydrolysis. So what is happening? First one, magnesium carbon dioxide hydrolysis. Treating with the magnesium, you get a Grignard reagent. There is methyl group here. Here you will get MgBr, Grignard reagent, isn't it? Grignard reagent. Now with the carbon dioxide hydrolysis, you get benzoic acid. There is methyl group here and this will turn COOH. Preparation of carboxylic acid using carbon dioxide Grignard reagent, you get benzoic acid. Now the second reaction, SOCl2, you get benzoyl chloride. Acid chloride is obtained. You get acid chloride like this. There is a methyl group here and you get COOH turn COCl after the second sequence. Then Lindlar's catalyst, Rosenmund reduction. What is happening? There is methyl group and this will turn Rosenmund reduction. COCl will turn CHO, Rosenmund reduction. And the last one, Clemmensen reduction. Here we had a Wolff-Kishner reduction. Here we had a Clemmensen reduction, and the result is once again orthoxylene. So second choice is a perfect answer, isn't it? So first choice, second choice, both are answer. What about the third one? Third one, first it is hydroboration oxidation. What happens? Hydroboration oxidation. You can see there is methyl group here, and here you will get alcohol. This ethyl group, no, it will turn alcohol, and the OH group comes at which position? Terminal position. OH group will come at terminal position. Hydroboration oxidation reaction. So that is hydroboration oxidation reaction. Now with the Br3, what will happen? OH will turn Br, and now zinc with the diluted Cl, reduction. Reduction happens, and this will turn what happens? Alkyl halide will turn alkane. Alkyl halide will turn alkane. The final product will be like this. There is methyl group here, and there is ethyl group here. This turn ethyl group, this halogen is gone. You get methyl ethyl benzene. We want xylene. We don't want methyl ethyl benzene. We want xylene. So option C is out. A in, B in, C out. What about D? What about D? First one, ozonolysis. First one, ozonolysis. Here there is ozonolysis reaction happening, and the result will be like this. No, there is benzene ring here, and here it turns CHO group, and here it turns CHO group, isn't it? This carbon will turn CHO. This carbon will turn CHO as a result of ozonolysis. And now what is happening again next? This is Wolff-Kishner reduction. Wolff-Kishner reduction, both the groups will turn alkane group. Both the groups will turn alkane group, and the result is this is methyl group, this is ethyl group. In fact, the same result. So C and D give same result, and that is also out. C and D will give same result. A and B will give same result. C and D will give same result. A and B you get a xylene, C and D you get a methyl ethyl benzene. Isn't it? Isn't it? So that can be another way of asking the same question in a different way that can be asked. A and B, choice A and B, you get orthoxylene. Choice C and D, you get a methyl ethyl benzene. So our answer will be only orthoxylene. Our answer will be, it is A and B for the particular question. Yes, that's all. We will meet with another question in another class. Bye. Take care. See you.